Primary Hydrogen is an acquirer, explorer, and developer of natural hydrogen projects in Canada and the US. Ben Asuncion is here outlining the company's plan to acquire, explore, and develop these natural hydrogen resources with over 740 acres of projects in the US and 210 square kilometers of projects in Canada. I'm Martin Gagel with Market Radius Research. Please remember, this is neither a recommendation nor investment advice. We're here to learn about the company. Ben, thank you very much for joining us. I'm really looking forward to this. there are not a lot of natural hydrogen stories out there, and this is my first one I get to learn about. So great to have you here, and let's hear what you got going on.
Perfect. Good morning, Martin, and thanks for the opportunity to present Primary Hydrogen Corp. Before we delve in, I kind of just want to give you some background or context of the company. So it was originally founded in July of 2020, and we IPO'd in August 2021 as Millbank Mining Corp. Now, last summer, the company strategically shifted its focus to hydrogen. It raised $4.3 million in the back half of last year, rebranded to Primary Hydrogen Corp, and has since built a portfolio of 10 projects across Canada, the United States. And just to give you a bit of background on myself, I was a mining analyst for 10 years and have spent the past 18 years in the capital markets, basically evaluating and valuing assets or projects in addition to raising capital. So this brings us to Primary Hydrogen and why hydrogen. So why the company shifted its focus last summer is it was looking for disruptive markets which provided significant growth potential. So why hydrogen? Well, hydrogen represents one of the cleanest, universal, portable energy sources available. It has applications in fuels, power generation, in addition to industrial applications, and this translates effectively into one massive target addressable market. Now, one of the things that we're always looking for is investment opportunities, and we saw significant and expanding investment opportunity within the hydrogen space. Now, this was driven both by green and climate initiatives, with the adoption being pioneered by Europe, in addition to other countries around the world. We also saw a significant amount of capital flowing into the space, which supports its ultimate growth. One example of this is the Bill Gates-backed startup, Coloma, which is a private company, and has raised over $400 million US to date. Now, we also saw significant government support. This was in Canada and the United States, which was highlighted by grants and incentives, which helped to accelerate adoption and development. So within the hydrogen space, where does hydrogen come from right now? Well, about 80% of the current supply comes from the processing of fossil fuels. Now, this is both costly and potentially generates significant emissions. The balance, or about 20%, comes from produced through electrolysis, which uses large amounts of energy, typically renewable, to produce hydrogen from water. This is very costly from an energy standpoint and often less efficient. And this really highlights the part of the market that we saw the greatest opportunity here, and that is in natural hydrogen, as it's renewable or regenerative, clean, and most importantly, cheap. So one of the factors driving growth is or growth in demand is the ubiquity of its applications, right? That ranges from power generation, fuel, heat generation, as well as its use as an industrial feedstock. And ultimately, only natural hydrogen has the ability to offer cost parity with hydrocarbons. That is, without subsidies or credits, which is paramount to its long-term success and adoption. So within natural hydrogen, there's a variety of geologic environments that create hydrogen naturally. So the generation of hydrogen is a very common reaction in nature, and it occurs in a host of different environments. And since this is a naturally occurring reaction, it really highlights the potential for hydrogen sources to both be regenerative, which is unlike conventional mining or oil and gas. So just to give you an example of one of these generation methods is serpentinization. So this one here on the top. And the easiest example that I can give you is if you left a piece of iron outside, it would rust as it's exposed to the elements. This rusting is the result of water interacting with the metal, which produces hydrogen gas. So within our project portfolio, all of our hydrogen projects have exposure to either one or multiple of these potential generative sources. And that brings us to our portfolio. So we've taken a portfolio approach to exploration, given exploration's inherent risks. And this provides diversification across both potential deposit types, in addition to geographic and geopolitical diversification. So the portfolio spans over 240 square kilometers of natural hydrogen and, to a lesser degree, critical minerals projects, namely copper and rare earths. Now, we have active exploration programs spanning the entire portfolio, so across all projects this summer, which means a significant amount of exploration-driven news flow for investors. Given the size and breadth of our portfolio, we take a systematic and phased approach to exploration. Essentially, we start with a high-level reconnaissance work, which drives target generation and ultimately guides our field exploration and sampling programs. As I previously said, we're now at the start of our field exploration phase, which carries us through to the end of the summer. Following on from encouraging samples, the next phase would be additional geophysics, potentially additional sampling, and ultimately with the goal of deriving drill targets. Now, as we have 10 projects, we have information presented for each of these projects in the following slides, which I'll largely leave for your audience to review. And I'm happy if they want to reach out, if they'd like to discuss or go into any other projects in specific and detail. Now, this brings us to our team. Now, natural hydrogen, I like to think of as like a hybrid between mining and oil and gas. That is, it's usually based on more conventional geology to identify prospective environments for it to occur and accumulate. However, the development and ultimate production of these resources is more akin to oil and gas. So we've assembled a team based on individuals with significant technical expertise, both in conventional mineral exploration and oil and gas production and development, in addition to thought leaders and pioneers in the realm of natural hydrogen. So I've already spoken about myself, a few other team members that I'd like to highlight here. For example, Peter Lauder, our VP of Exploration, is an exploration geologist with over 20 years of experience with companies like Gold Corp, IAMGOLD, and BHP. We've also built a strong team of technical advisors like Stefan Sejourn, who is one of the pioneers of natural hydrogen exploration in Canada, and Allegra, who has extensive experience studying natural hydrogen systems with backgrounds from Stanford, MIT, and the USGS. And lastly, just to wrap off our capital structure, we currently have just under 41 million shares out, which implies a market cap of about 18 million. Based on the capital raisings completed to date, we're fully funded for our exploration program this year across the entire portfolio of projects. So this is expected to deliver significant news flow throughout the summer and through to the end of the year. And I will leave it there. If you have any questions, Martin.
All right, thank you very much. And a reminder for the audience, type in any questions that you have, but I've got a ton. So I'll keep us going here for a while. How well understood is the regenerative nature of the hydrogen underground? And I understand there are two processes, and I can't actually pronounce them, or they're not on the top of my head. Can you just kind of go through a little bit of that, like do a little bit of a nerdy dive into the chemistry, I guess, behind that?
Okay, so hydrogen or the generation of hydrogen is a very common reaction in nature. It happens all the time. The majority of the hydrogen that is created in this natural process effectively off-gases. So it comes through the earth and it evaporates into the environment, and this process recycles. Now, when you touched on regenerative, there are case examples that support this. So for example, there is a natural hydrogen discovery in Mali. Right? When they initially made that discovery, they measured the rate and pressure of the hydrogen that was coming out of the well. They went back a number of years later and found out that the pressure had actually increased, right? So because these are naturally occurring and very plentiful reactions, right? If you find the right source that has the right regenerative source with the right characteristics around it, and effectively you're looking for two things. You're looking for something that creates the hydrogen, right? And something that traps or contains it or confines it, right? So you can accumulate it in much larger quantities, right? And within those two contexts, you can definitely have sources that would replenish, right? As long as the source or the generation method has significant ability or interaction in order to do so.
Yeah, and I guess like just going very basic, hydrogen is an element. You can't. It doesn't just get created. I guess the H would get stripped off an H2O or water molecule, or broken off of some other mineral or a hydrocarbon or something like that. And there's a catalyst that kind of triggers that separation.
Totally. So, I mean, taking the very simple example, so serpentinization is the interaction between iron and water, right? And this is the example that I tried giving. If you took a piece of iron and you left it on your porch and you left it exposed to the elements, it rusts over time, right? That rust is an oxidation process. So what happens is the iron interacts with water, which is H2O, right? In that interaction, the oxygen binds with the iron, right? That creates an oxidized iron or rust, and the hydrogen is released from that reaction. This also goes to when I talked about where hydrogen comes from now, right? 80% is fossil fuels. The balance 20% is through electrolysis. And electrolysis is effectively running an electrical current through water, right? I think we've probably done this as a high school experiment. And you get bubbles that form, right? When you run the current through it, you break apart the H2O into oxygen gas and hydrogen gas.
There's also a radiolysis process. I don't know. That sounds like it's maybe something to do with radioactivity breaking apart things.
It is. So radiolysis is an interaction between radioactive elements, right? That interacts with groundwater or superficial water, right? And that causes the generation of hydrogen, right? So you have it created through iron, radiolysis. There's also deeper seated, very deep faults or magmatic structures, right? Similar types of environments that create oil and gas deposits, right? Can also create hydrogen seams or reservoirs.
All right. So do you guys have any a bit of a sense of how deep underground these hydrogen, not, I guess, where it's produced isn't so important, but where it ends up accumulating under some kind of dome or unfractured structure where it can kind of accumulate. Do you have a sense of generally how deep these areas are?
Well, I think within our, initial targeting, we're looking at things that would be within the first 500 meters and not really looking deeper than that. But, just to explain, this is an exploration process in a industry that doesn't have a ton of precedence, right? This is a new and emerging industry. So, our thesis first is looking for environments that have the right geologic features that can create hydrogen. Second to that, are there geologic features that will allow it to be trapped, accumulated, or funneled or focused, if you will, right?
Yeah.
So our first phase is looking for hydrogen as it seeps on surface. That's what we do in a soil or a field program. Following that, geophysics will help us to refine the structure of potentially where that's coming from, with the idea that we would follow up and drill test into that structure.
Yeah, when you're doing the sampling, are there byproduct chemicals or elements that are associated with it, or does a little bit of the hydrogen get trapped in the rock or the soil, and you take a sniffer of sorts and say, oh, we got elevated whatever ppms of hydrogen here in this area, and that's indicating something?
Yeah, essentially we're looking for hydrogen that's either dissolved in water. So if there are water features over the project, streams, lakes, you do get hydrogen dissolved in water. There's evidence of this in Quebec with exploration in that province. And also we're looking for hydrogen that's trapped within the soils, right? Because this hydrogen's percolating through the Earth's surface. It finds cracks and ways to escape. It's a very light molecule, right? And it tries to bubble out and enter our atmosphere. So typically you'll measure hydrogen, nitrogen, and, effectively oxygen in most of these environments.
Okay. And so you're doing the initial sort of typical mining company work, sort of the sampling and geophysics over the summer. Do you, and just going back to the slide maybe where you've got your milestones or your sort of that one. So, okay, you'll do, okay. And then, so this year would not consist of actual drilling. This is you're accumulating lots of data and then going back to the lab, so to speak, and try to correlate everything.
Well, so not necessarily, right? So the phase that we're at right now is drilling is the highest risk and highest cost part of exploration, right? So we don't
Yeah.
want to blow a bunch of money on testing targets without having a very strong and refined image of what the concept and what the model is. So
Yeah.
this summer, we go through field programs, right? So if we get very encouraging positive results from the field program, we shoot geophysics essentially just to try to understand the structures, right? And
Yeah.
where we should drill within that area. And then ultimately, we could be in a position to drill before the end of the year, like in the fall or in the winter. Now, that presupposes that we get positive results through all the phases, right?
Yeah. Yeah, you're obviously you're getting as much sampling, and then your first drill hole is going to go presumably somewhere where you get enough statistical. You get the highest likelihood that you'll find something.
Yeah, we're looking for, we see hydrogen on surface, so we know it's coming from somewhere, right? Because
Yeah.
hydrogen comes out of the ground and into the environment, right?
Yeah.
The geophysics will help us understand potentially the structure, i.e., the pathway or road that it's coming out through the ground, if there are
Yeah.
any big controlling features. And then ultimately, that would allow us to formulate our best guess for a drill target, right?
And maybe the exploration is mining like, but production is oil and gas like. I get is that a fair way to maybe structure it?
That is, right? So for these environments, so we're looking for geologic characteristics, right? The right environment that can cook or the kitchen or source for hydrogen generation, right?
Yeah.
So that's more conventional geology, right? The sampling and everything else we do is also similar to conventional mining. When
Yeah.
you start drilling a well, right, you are then able to test flow rates, concentrations, and more time duration, i.e., how does the flow rate or pressure change over time? Does it increase? Does it decrease? Do the grades change? That really becomes more of a oil and gas exercise at that point, right?
Okay, and are you using mining drilling rigs like RC kind of rigs, or are you using more oil and gas type of rigs to do your drilling?
So for what we would be looking at, if we're looking at drilling a exploration well, right, or hole, if you will,
Yeah.
that would allow us to test, right, over time, we could use conventional diamond drilling, right, which
Okay.
is more cost effective. If
Yeah.
we have multiple drill targets that demonstrate high grades, high concentrations, and high flow rates, and you're ultimately trying to develop a well field, i.e., how do you extract the maximum volume from your resource at that point? Then you'd probably use more conventional oil and gas rigs because you'd want to screen and case and be able to filter a little bit differently, right? For the purpose
Yeah.
here, we basically want to poke a straw into the ground, be able to sniff
Yeah.
what's coming out, and see how that changes or reacts over time.
Let's say when you do find hydrogen, you develop the project, or you're developing the project. I guess the infrastructure would look a lot more like a gas well as opposed to like a mining operation. And to me, that means then you need a pipeline, and so you can't truck this from, I don't know, or maybe you can truck it out. What would and looking at your projects, did you choose them just on the best geology associated with it, or are you looking at, okay, good geology and got close to relevant infrastructure?
So it's really been both. We try to pick high geologic targets, right, with a viewpoint on how the ultimate development would look. So you are
Yeah.
right that it would look like an oil and gas production. Now, let's fast forward and assume that we're producing hydrogen. So it comes out of the wellhead, right? We can
Yeah.
pipeline it, right? We can also pressurize it so you can have liquefied hydrogen. And then the
Yeah.
other option is you can make green ammonia. Now, ammonia is a fuel source similar to diesel. So there
Yeah.
are ocean-bearing freighters that run on ammonia. Ammonia is
Yeah.
obviously an agricultural product, right? But you can convert it to ammonia. It's much more stable. It's a liquid that's not under pressure, and you can
Yeah.
truck it. So there are different ways, whether you keep it as a gas, you liquefy that gas, or you
Yeah.
transform it, right? You can even
Yeah.
create green methanol or any hydrocarbon you want, right,
Yeah.
out of the hydrogen.
Yeah. And instead of cracking the hydrocarbons to get different things that they do in Alberta, you'd be sort of adding molecules onto the hydrogen to create your own custom hydrocarbons. Is that kind of how it works?
Correct. You'd be kind of like undoing the cracking process, right? So you'd be
Yeah.
combining it with carbon to create whatever branch chain carbon product that you want.
Yeah. Or you could put like a data center or bit mining thing right next to it and just burn it, and then we don't have to move the power anywhere. Sorry if I'm being silly here, but it's sort of
No
half
worries.
silly there.
No worries. Look,
Yeah.
ultimately, there's a lot of ways to address that. I think right now
Yeah.
where the industry is making discoveries, right?
Yeah.
Most of the hydrogen comes from either expensive or dirty sources, right?
Yeah.
So with this new advent, as you get adoption, and as I said, natural hydrogen has the ability to deliver cost parity. And cost parity, according to research right now, on a trade-off with hydrocarbons is about $1 per kilo or less, right? When you produce it
Of the
from,
cost, your cost to get it out. Is that what you're saying?
correct, if you can deliver at $1 per kilo, it
Yeah.
is in price parity with natural gas and other
Okay.
hydrocarbons, right?
Yeah.
So when you're producing hydrogen from hydrocarbons, you're probably $2 to $4, right? Maybe $2 to $6, depending if you have carbon capture. If you do
Yeah.
it with green hydrogen, i.e., renewable energy, you're
Yeah.
probably 2 to 4 times the cost of producing it from hydrocarbons.
Yeah.
So natural hydrogen, from industry analysts and research, has the potential to deliver, sub $1. So let's call it 50 cents to $1 per kilo, right? And that's
Okay.
really where natural hydrogen makes the most sense, right?
Okay. And that would then be about, still, let's call it $1. That would be about half the price of a hydrocarbon hydrogen.
Probably less. So
Okay.
when you produce it from natural gas, if you
Yeah.
don't have a carbon capture, right,
Yeah.
then you're probably $2 to $3. If you do have a carbon capture, you're probably $4 to $6, right?
Yeah.
So it depends on your regulatory environment, let's say.
Yeah. And then, of course, it also depends on what the going rate for natural gas is at the time.
Correct.
So, in terms of the regulatory environment, who are you talking to, the oil and gas regulators or the mining regulators, or like in your drill permits? Like, is there anything interesting, or like how do the regulators view you?
So from a provincial or let's call it state regulation perspective,
Yeah.
it varies widely. Within the United States, it falls within, ultimately within oil and gas. Within
Yeah.
Canada, it really depends on the province that you're in. So a number of provinces don't have specific carve outs yet for hydrogen.
Yeah.
So it falls under mining. But I expect as the industry develops and as you have more projects advancing, that you'll
Yeah.
have a regulatory environment that supports that. And ultimately, Canada, through the existing regime, has a lot of support for green projects, right?
Yeah. Yeah, and mining. So like what's get green mining and or oil and gas. That would I think a lot of politicians would love to stand behind that, next
Mhm.
to that project. I guess it's too early. Like ultimately, you would be dealing with offtake arrangements and so forth. But have you had any even preliminary sort of, hey, this is what you're doing to potential off takers, and sort of just testing the waters on what they think about the situation?
We've had discussions with them. I don't want to hamstring the projects until I really understand what the opportunity that's presented there is. But I
For
can
sure.
tell you that there are off takers that have approached us,
Yeah.
and there are terms on the table. We
Interesting. Oh,
we are not looking at advancing those again
yeah.
until we really understand what we're dealing with here, right?
And just a little bit explaining on hydrogen, because there are a bunch of very interesting terms. Maybe you can clarify them for investors. Natural hydrogen is sometimes called gold hydrogen, I believe. And then there's green hydrogen and brown hydrogen and blue hydrogen. Maybe walk us a little bit through all of that. Okay, you've got that here, but let's just sort of
Yeah.
clarify that some more.
So they call it the hydrogen rainbow, for lack of better
Yeah.
words, because there's different colors based on the different sources. So
Yeah.
natural hydrogen is either referred to as white hydrogen or geologic hydrogen or natural hydrogen, right?
Okay.
Gold or orange typically refers to stimulation, i.e., introducing catalysts or reagents to provide
Oh.
more, to facilitate a greater reaction at that source. So you find the
So,
environment that's,
sorry to interrupt. That'd be almost like the kind of equivalent of fracking. You're like fracking it, adding stuff sorry, maybe a bad analogy or stretching it, but you're intervening in the whole process.
Yeah, you're effectively just adding more fuel to the fire, right?
Yeah.
You're adding more material for a reaction. Within other spaces, so you have gray hydrogen that we outline here, right? That is from natural gas, but without any carbon capture, right?
Yeah.
So it produces CO2, right? Then you have blue hydrogen, which has carbon capture, right? You have
Yeah.
green, which is from renewable energy sources. This is like wind or solar. There are even offshoots of this. I think it's called purple or pink hydrogen that uses nuclear power as the
Okay.
input source. So
Yeah.
there's a variety, but effectively it's either electricity and water through
Yeah.
electrolysis, different colors based on the input of the electricity, and
Yeah.
then gray, blue based on, how much carbon you're recapturing or sequestering, right?
Yeah.
And then within the natural hydrogen, white or geologic is what we're looking at, right? Which is
Yeah.
happening on its own. There are a few other color offshoots where they basically look to introduce more catalyst to speed up or provide more fuel for the reaction that's already naturally occurring. So it's not
Yeah.
fracking to create pathways. It's basically introducing, like throwing more wood onto the fire.
Okay. Okay. And you mentioned this with the electrolysis, because one thing with and especially what you do with the hydrogen thereafter, if you take electricity to convert that to water, then break that up into hydrogen, there's a lot of heat generated and waste. So I think it's I don't want to say a number because I'm not sure of it off the top of my head, but there's a bunch of ways. So if you get a kilowatt of power, some of it goes into the fracking or the cracking process, other goes to just waste heat. And then if you use that and then you use that again in a fuel cell, then you have loss of efficiency. So the more processes you go through, the less efficient the whole process is. So doing it green is or doing it white is sort of the cleanest of them all, I guess.
It is. So, green hydrogen is clean. It's just expensive. And
Yes.
we've all seen the headlines. So, you threw out Bitcoin mining, right? So we have AI and Bitcoin and other things chasing for very scarce energy or electricity infrastructure right now, right?
Yeah.
So it's hard to position this to also draw from that same application, right? That's really what
Yeah.
makes it costly and inefficient.
I'd like to switch over to your cap table a little bit and your balance sheet. You've raised these are interesting times in the, and for this part of the business, I'll put you more into the mining exploration bucket. You've got what, $4 million in the bank right now, or that's how much you raised?
So we raised just over 4 last year, right?
Yeah.
And that is funds that are being committed towards exploration, project acquisition, project review, looking for new opportunities, and general working capital purposes.
Yeah. For a very early stage exploration and a whole new and an early stage industry, that's a considerable amount of dough, and you've got a decent share price there. Can you talk a little bit about your shareholder base and what kind of support you're getting from, and I don't know if you can drop any names, but the type of investors that are involved with you? These seem to look like sort of longer term players, not the sort of let's get a drill, sample and run kind of investors.
Yeah, we've been fortunate. We've got a very supportive shareholder base that has, followed us through, successive financings, right? So, I mean, our two most recent and material financings, we raised 3 million at 33 cents last year, and then we raised another 750K at 40. Right. So we've had strong support both from what you would expect in the Canadian market. So that is the who's who of brokerage firms, in addition to, institutional ownership, I think is probably about 6%. Right.
Okay.
So we have the right audience, and we have an audience that sees an opportunity within this space and is giving us an opportunity to run with it.
You've laid out what you're going to be doing, and I guess you're going to have you'll have news release as to sort of some of the kind of type of data you've received, and I guess you'll help explain to the world if that's positive looking or neutral or what. But I guess can you maybe help us? You obviously can't say what you're going to find, but what type of news flow and what should investors be looking out for?
Okay, so from what we've done, we've within our broader project portfolio, we've narrowed down targets for our first phase. So we're going to be in the field that's already starting, and was really more constrained across Canada by weather, right? So we don't want to do any sampling when there's snow cover or it's wet, because we don't want to influence or artificially introduce things that might sway the results or the readings, right? So we basically needed to wait for snow cover to clear and the ground to be generally dry. So the news that you're going to see coming out is going to be soil and gas sampling and assaying coming from effectively all the projects within the portfolio, right? And that will trickle out over the course of the summer. We do get readings initially, right, from a probe that goes into the ground, but we also do, as part of our QA QC process, we validate with external samples. And specifically for, for example, for Ontario, we announced we had a partnership with the INRS, and we are working with them on a research program to determine the optimal sampling methodology where you don't introduce or skew the sample results, right? So we've partnered with them and we will work with them. So we've got a lot of, let's call them double blind type of sampling processes, but you'll see those results coming out throughout the summer, right?
You said you're going to be working on all of your projects. Is there an emphasis on one of them, or are you just going to give each one the appropriate attention and then see where that data leads you next?
So within the portfolio approach, we do the same first pass. We have identified the most prospective areas within the projects. We're deploying teams to field sample those. Once we get all the data back, then we determine the best allocation of funds, right, to which projects in terms of priority or ranking. So I don't really want to skew and say, a favorite project here or there. They all have their own attributes. And ultimately, I'd like the data to support the reason for the next decision and further expenditures and development on that project.
I think we've covered everything. Anything else you want to highlight or mention we didn't discuss, or just tie a bow on it? And any final thoughts for people?
No, I think you had a great level of questions and quite in depth. I think just the final word I'd like to leave everybody with is, this is an industry that is continuing to grow, on a day by day basis. Right? This is the early stage of the industry where companies are making significant discoveries. So I still think we are on the very front end of what the hydrogen uptake curve could be. If we looked at parallels to other spaces, lithium, for example, those adoption curves, right? I think this sector presents an excellent risk-adjusted or a risk-reward trade-off for investors. And I think we provide investors with a significant amount of exposure across projects, geologies, as well as geopolitical.
Ben, thank you. I really enjoyed that. That was fascinating. I learned a ton, and I'll definitely be watching your progress over the coming summer, and love to get you back and maybe talk about some of the results you get as you go forward, and we can sort of. I think we'll be learning a little bit as well as you're learning things, so we can do this process of it together.
Definitely. We look forward to it. Thank you very much for your time, Martin.
All right, Ben. Thanks. Have a great day. Cheers.
You too. Bye-bye.